Let's get moving. All right, welcome back. We are GAME3001, that's Artificial Intelligence for Games, in the winter 2022 semester at George Brown, and it's week 2, part 2 of our broadcast and recording and session. And we're going to be talking about a couple things today, so class did start at 2. And let's just recall what we talked about during our lecture. In our lecture, we talked about steering behaviors and kinematic movement, mostly. We talked about, and notice that in this week, we have 2 parts to Lab 2. So part 1 is this week where we set up, and part 2 is where we finish. And that's when Lab 2 is due. Lab 2 is due January 30th at midnight. That's a Sunday. Okay, just letting you know. So those 2 labs are critical for you to do your assignment 1. And that's why we've kind of put them in this way. You learn about the engine, and you also learn about creating game objects, simple collision detection, and movement. Those are all the things you're going to learn over these 2 labs. So this week, what are we doing? Well, Alex has a bunch of little instructions for us because he ran the class earlier today. Oops, not that one. And we're going to start off at the top with downloading the new version of the SDL engine. So what happened is, what Alex did was he went up and he updated SDL engine to version 0.27. So the first thing we're going to do is download the engine again, and we're going to put it into place, put it up on GitHub, and do those kind of things. Let's get to it, and then I'll let you know when the challenge starts. Okay, so first things first. What we want to do is we want to put together or download this engine. So I've put together a little space for you in your downloads folder, so I can do this kind of stuff. So this, you guys are group 400. So this is where I'm going to put that stuff. And I'm going to download it here. So the way you download the engine is you go to the engine link. This is the pin link. And then notice that this is version 0.27. The comments for what's been changed is right here. 2 ways to get this. You can grab it from here like we talked about, or you can just go click here and then download, whatever you want. I'm just going to use this method. So again, download. Once I have the download, it won't be that long. It's not a big group of files, right? What I want to do is I want to grab it and expand it. And I'm just using this as a workspace right now. That's all I'm doing. So I can get everything I need ready to put into my lab. So again, I'm going to just drag that in here. And I'm going to right click and I'm going to extract it here. So the first thing I do is just get it. We don't need the zip archive anymore. Goodbye. And we can rename this thing to Lab 2. There's Lab 2. Okay. We can take this Lab 2 and we have a containing folder that we already had from last week. And if you remember what it was, right? And in our containing folder, I put it on the desktop. So I put it in here. And I have a section for you guys, section 400. And notice we had Lab 1 in there already. So what I want to do is for section 400, I want to kind of, cut this one out of here. This is just my workspace, right? And I'm going to just drag and drop it in there. Now, could I have put it directly in here? Yes, but I find it's just a little easier to handle when I can do my work here in the operating system and then bring it across. I highly recommend this approach because then it reduces errors. Next, here's my workspace. And one thing we've asked you to do in Alex's directions is, hey, let's download that ncl.png from the Lab 2 item. Okay, cool. So that's up here. If you look in the Lab 2, there is an ncl.png. Let's download it. So download, so right click and save image as, and put it into the right spot. So under downloads, we want to put it into, for me, it's you guys 400 here. And save. There it is. Okay. So now I have both things, and you can see now I have my NCL. That's my image, right? And we can inspect it with your favorite application. In fact, there's a great application you can open it up with for free. It's called Photopea. Maybe I've talked about this with you before. Photopea is like an online Photoshop replacement for free. So I can open it up on my computer, right? And I can go to the place where I put your files, which is in 400. and I see that I have an NCL here, and I can open that up. And you can see when I open it up that there's no background. It's black completely. If I open up the page and look at the bitmap clearly has a transparent background. So as is, it's pretty good. I don't have to do much. It's a little big, but who cares? We can modify the size a little later. So that's Photopea, right? And again, I think we've talked about this before, but I'll put this in the chat so you can always get that. There's Photopea, and I also put it inside of YouTube for those people watching on YouTube, right? So that's how you look at it. You can inspect it. It's pretty good to go. But what we need to do is we need to move it into the right spot, okay? Because right now our little object here is not in the right spot, okay? So let's put it in the right spot. So I'm going to bring up both of those little letters. And you can see that on the left, there's Lab 2. Let's swim into the Assets folder. So I'm just navigating in here into the Textures folder. Okay, see there's a bunch of other textures in here. And I'm going to grab NCL and just drag and drop. And now it's in the right spot. Okay, there's NCL.png. It's inside of the GAME3001 Lab 2 Assets Textures folder. Cool. We're ready to go at this point. Let's just get rid of these windows. I don't need them anymore. I've done pretty much the first piece, okay, of what Alex asked us to do. So let's open it up. So again, for me, what I want to do is when I start off, again, it's inside of my my containing folder is GBC, and you might be different, 3001, section 400. And remember what we did there before is I want to put this straight up on GitHub. So we used GitHub Desktop. Let's see how that looks. And here's GitHub Desktop. And what I want to do is I want to open the right one. So that's section 400 labs. There it is, right? Section 400. And if you notice, I've added in 954 files. That's all the files from my lab 2. Sounds like a lot, but it includes libraries and a bunch of other stuff. Cool. Let's say that we've added lab 2 project files and commit to main. And then once that's done, I'm going to push it to GitHub whenever this feels like doing what it's supposed to do. There it is. And we're done. Cool. So when I look online now, right? So if I go to github.com/George Brown College and I look here, I can clearly see that this one has been updated, right? And this is including lab 2. Guys, some of you last week when you submitted your lab, you just submitted this part, just this alone. That was your main lab. There was no containing folder. You need to make a main folder, a main repository, or a master repository, call it what you like, that has all of your labs listed here. Okay, some of you did not do that. Okay, and there's a bunch of other issues that I noticed when I was looking through the code. You're going to get marked soon. I was waiting for people to resubmit. Some people are new to the course as well, and a bunch of other people like that. So we wanted to give people a chance to do that. But that is the way your repository should look right now. Okay, so added lab 2 project files. All right, so that's the first piece. And let's go to the next one. All right, so now I want to open up lab 2. So here's lab 2. And I want to double click on the template.sln file. It's going to bring up Visual Studio 2019. And there's the first steps that we're going to do. First steps are we're going to change from x64 to x86 to avoid any weird problems. And then what we're going to do is in the solution, on the solution file, we're going to right click and we're going to select retarget solution. Again, because my SDK and your SDK might be totally different, I highly recommend you do those 2 steps every single time when you start. Great. Well, to get ready, Alex says we have to add stuff to or remove stuff from our play scene. But right now, because we started a brand new lab 2 folder, we need to reset our scene. So it starts with the play scene, not the start scene. Because if I run it right now, just to give you a sense of it, it will only start the start scene. And we kind of went around that last day, right? So we're going to kind of go back to this and we're going to talk about it. Just so you're, you know, kind of, you can follow along. Okay. Please stop me if you have any questions. So notice here, we're in the start scene and it says version 0.27 because we've updated our STL engine. And what we want to do is get rid of all this stuff. We don't want to have anything in here whatsoever when we start. Okay, good, good, good. Let's first of all modify our code so that way it doesn't start in the start scene, it starts in the play scene. So again, that is in singletons. Under singletons in game.cpp, what we want to do is we want to navigate to the start function. And in the start function, it says, hey, start with the start scene. We don't want that. We want to start with the play scene. So this is a bit of a review from last time. In the real world, when you make your lab for AI lab 1 or your assignment 1, right, you don't want to do this. This is just for you to work within the play scene. When you're done, start with the start scene because that's where your name and student ID is going to be. All right, so now that we're doing this, we can run it and we can get right into the play scene. And you can see that this is where we kind of left off last time, where we had a little bit of movement. We removed these buttons and everything else. But today, Alex has asked us to remove everything, right? How do we do that and not break our code? Okay, well, we know that we have to remove everything from our play scene when it comes to the UI elements and game objects. Let's do that now. We start with the .h. So in our .h file, placing.h, we have several elements here. Our plain, player, our Boolean for the player facing, our UI items, all of these have to be gone. Goodbye. And we're not commenting them out this time, we're just deleting them. And on the top, you can see that there's a few includes that you need to clean up. So we're just getting rid of all these includes. Goodbye, includes. So we don't need them anymore. And save. Cool. Well, that creates errors right now, a lot of errors in the playscene.cpp. Let's just move this over here. And you can see that there's a ton of errors, right? These are all the errors. Why? Well, we don't have any more of those things we were looking for. So let's scroll down and really in the handle events function, let's start there. Let's get rid of all the references to movement of my ship, my player. Let's get rid of all that stuff. Goodbye. And that kills everything. But we don't want to kill the is key down for the escape to stop the game, or 1 and 2. These are little hotkeys or cheat codes that allow us to go from one scene to the other. Okay, so we don't want to change those. So let's just get rid of some of those empty spaces. And that right there is our handle events scene, function. Right, so we just got rid of the stuff that was erroring out. Next, I need to get rid of all this stuff, all of it. We're not going to get rid of the title, m_GUI title, which is the play scene. We're not going to get rid of that. But we're going to get rid of everything else. So all the way down to where it says, I am GUI window frame. We're not going to get rid of I am GUI window frame. We're going to keep that and delete. Cool. And that, my friends, cleans out our scene. There we go. It's a clean scene now. Nice, 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 right? And what that does is there should be nothing that's in the scene now. Let's run it. And you're going to see a white screen. White screen. Awesome. Let's put this up on GitHub. So again, what I'm going to do is I'm going to go here, right? You can see that there are several things we changed. And I'm going to say that we cleaned start scene. Oh, sorry, play scene. Removed game objects and UI. Okay, commit to main. And we're going to push to the origin remote. And again, when you look at this up online, notice I did another commit. When you look at this up online, if I refresh, you can see that now there are the changes that I put in there. Take a look at that, right? Clean the play scene. And if I look inside lab 2, only the areas that have been changed are going to get that commit. Excellent. Nice. All right. I like it. Clean the play scene. And let's do the next one. So again, what we're doing is we're following Alex's requirements. That's up online. on Blackboard right now. If you look at Blackboard, he's put in lab 2 steps / requirements right here, part 1. That's what we're doing right now. Okay, so let's go back up there. And we've removed all this and done this. This part and this part is done. Those two pieces. Okay, let's do this one together. So in this case, I'm going to show you how to add a target game object to this play scene. The target. Okay, how do we do that? Next. Well, let's start with the playscene.h. We can see that inside of the game objects folder, right, there is a target.h and a target.cpp. Let's take a look at those. Target.h and target.cpp. Target.h is the first file, and notice that every single time I make classes, I have, and Alex too, we have two pieces: the .h, which is the interface, and the .cpp, which is the the definitions for all the functions. That's what those two things are. Okay, so that's the target. And what I want to do in the playscene.h is the first thing we need to do when we add in a new game object is I'm going to include it. So target, and it should come up. Okay. And then what I'm going to do in the target is this is where our game objects are going to be, right? So in our game objects, we're going to add a target. We're going to say, hey, target, I want a pointer to an object, to a target object. I want to call this m_p target. Why this naming convention? As a review, m is member variable, underscore is private. We're in the private area, right? P means pointer. m_p means a pointer that's private, that's a member variable, right? And the name of the identifier or the variable is target. That's the first step. So name it properly. Step 2, once you've done these two things, right, now we're going to go to the playscene.cpp and we're going to skip to the start scene. Let's go there. In the start scene, underneath where it says m_GUI title, we're going to change this and we're going to add it to the scene. Remember that last week we talked about how whenever we add stuff to the scene, we're adding it to a display list. And we can use a function called addChild to do this. So let's do that. First, let's instantiate. So we're going to say m_p target is equal to a new target. What this is doing is we are instantiating a new target object, allocating memory on the heap. And we're making a pointer reference and storing it inside of m_p target. That's what's happening. So m_p target points to the pointer address where we start the memory allocation for target. That's what's happening. That's why we're using the new keyword here. New means pointer. Next, we're going to add the target to the scene with addChild. m_p target. Because a target, we notice that our target itself, if you look at the target.h, it inherits from a public display object. It can be added to the display list of our scene. Here's our scene, right? And remember that scene inherits from the scene superclass. Go to definition. And the scene superclass has a display list. It's a private display list. And what happens is when we call addChild, it takes the child and it adds it to the display list. That's what it does. And then we have two lifecycle functions for all scenes: update display list and draw display list. Okay, cool. I like that. Nice, nice. And so what does this mean for us? Well, in our playscene.cpp, that means we have two functions that do that. So in our draw function for the scene, we have draw display list. So when we add something to the display list, everything on the list gets drawn. And then when we update the scene, we also update our display list, which means everything in the display list gets updated. So two separate functions. Cool. So if we just do this, if we just do addChild, then it should work. Let's try it and see what happens. So play. And it's going to build. Hey, there's a circle. Wait, why is it up there? How come my circle started there and not somewhere in the middle? Well, let's take a look at circle or target. Our target is, again, inheriting from a public display object. That's the first thing, okay? And in our public area of our target class, we have a target constructor and a target destructor. We also do our guard up here. This is the guard area. The guard's other files, from including this file, target.h, multiple times. That's what this is. One part of the guard, which is up here, is very Windows specific, and the other part is cross-platform, which is for Mac, Linux, whatever. Okay, so that's the first thing. Target constructor and target destructor, we declare them. Then we declare overrides, virtual overrides for all of our lifecycle functions that are part of all game objects, which is the draw, update, and clean functions. We also have some custom functions for this target, which are including move, check bounds, and reset. These are optional. You don't have to put these in. This is specific to the target class. Cool, I like it, I like it. So what does target.cpp have? Well, here's the constructor function. In the constructor function, oh, what's going on here? Texture manager instance. What's going on here, guys? What does this mean? Texture manager instance. I don't get it. Help me out. What does texture manager instance mean? Guys, if you don't know this, when it comes time to make your games and all that kind of stuff and to do your labs, you're going to be lost if you don't get this right now. What does this mean? Why am I doing it this way? Anybody? There's only one word I'm looking for. Hey, there we go. It's a singleton. Thank you for that. Right? So awesome. That's what this is. I'm saying, hey, I want to go to the texture manager singleton. I'm going to go through the instance function, right? And after I go through the instance function, then I have access to the entire class, right? And I use the load method, right? The load method says I need a string name for the path. I need a string, a friendly string where I can store the object in my texture manager, because my texture manager has a texture map, right? Like a little dictionary of all the textures. So I can reuse them over and over again. I don't have to reload this twice in the game, right? And then I call, hey, texture manager, go through the singleton instance and get the texture size for that thing I just loaded, right? The circle. And then set the width and the height for my game object to whatever you found when you loaded it up. Texture manager has a way of doing that. And it's using SDL. We use SDL texture to do that. Then in line 12, we say, hey, get the transform position, right, as an example, and set it to a brand new vec2 object. Vector2 means a vector. It's a vector object at exactly 100 and 100. So that's why when we run this thing, the little circle, which is our target, appears on the top left corner of the screen, or close to the left side of the screen over here. That's why, because it's 100 and 100. And we do it here in the constructor function. We tell it what's the default place. We can override this in the place scene if we want to. I haven't. That's why it appeared there. We're also setting the rigid body velocity right now to 0, 0, which means we're not going to move, right? And we're also setting the rigid body is colliding Boolean to false. Then we're setting the type of the game object. This is used for collision detection. We're setting the target as the type of the game object. So that's what's happening in the constructor. In the destructor, we're just leaving it as default. In the draw function, what we're doing is we're saying, okay, I want to set up two automatic variables. One of them is X, the other one is Y. And I want to get the position, so I'm going to use get transform position X and get transform position Y, and I'm going to set those values to the X and Y variables here. And then I'm going to say, hey, texture manager, go through your singleton instance function, and I want you to call the draw method. The draw method is going to say draw what? It's going to draw the circle that you can find inside of your texture map. So go to that dictionary, find the texture that's associated with this name, circle. I want you to draw it at this X and Y coordinate, which is where it is right now, right? If this moves, then these will be different every frame, right? And I want you to draw it in this angle. So right now it's 0, so the regular angle. And this opacity, so it's fully opaque. And I want the center of the object to be centered. So the pivot point of the object is centered. That's what this means. And you can see that if you look at the draw, it has all those requirements. And there's one more, which is I can also SDL render flip. I can set that to true if I want to flip around an object if I need to. Here it's a circle. I don't need to do that. In my update function, this is interesting. I have a move function that's being called and check bounds. My move function actually does something. It says, okay, get the transform position and then start with the transform position, right? Add the rigid body velocity to it, right? After you've multiplied the velocity by 5, whatever that velocity is. Right now it's 0. 0 times 5 is 0. That's why it's not moving. It's just saying, you know what? We're not moving. We're just going to, whatever the position is, every frame is, that's where the position is. And there's no check bounds right now. So it's not, check bounds is actually being called for no reason, right? It's almost like a cleaned up function. So that's interesting. If I have a move that's adding my velocity 5 times my velocity to my current position, because that's what this is, right? Then what if I added a velocity, I changed my velocity in my scene? Let's try doing that. So if I go to my scene, and if I said, okay, that's cool. Let's change that velocity, m_p target, and I want to get rigid body dot velocity, and I want to make it equal to a new GLM vec2 object where I say the velocity is 1. So I'm going to set it to, a speed of 1 across the x-axis. If I was to run this, and if I'm right, then the little circle should move to the right. Let's try it out. Hey, look at that. And it's going to keep going forever because there's no way of bouncing it back or resetting it right now. Okay, cool. We don't need this. I just wanted to show you that that does that. Okay, cool. And we have our circle. We've added our target to the scene. Okay, excellent. Let's put this up on GitHub. So again, going back to GitHub, where we added a target to the scene. So we're going to say, that's what exactly we're going to say, added target to play scene. And commit to main and push. Excellent. Let's keep following what Alex told us to do. So he says, okay, add the target and okay, get target to move with sliders. Okay, get target to move with sliders. I like that. No problem. So the GUI function is down here, right? And there's a few flags we have here. We have our title for the GUI. So when we begin our GUI function, right? That's I am GUI, by the way. So that means that if I was to run this the way it is right now, notice that if I do control backtick, I have this little GUI function right here. Hey, look at that, right? And the little GUI window has a title and it has some flags. I can't move my GUI window around. I can't do that. Why? Because of these flags. It says, I am GUI window flags, always resize. Okay, number 1. What else? I am GUI window flags menu bar, supports a menu. And the last one is I am GUI window flags no move. No move means you can't move the I am GUI window. Let's take this away and let's see what happens if I want to move the window. And I also want to change the title to something else, like, lab 2 debug properties. Because that's what this I am GUI window is for anyway. And let's get rid of the button too. We're not going to need a button anymore. Yay. And run it. Let's see what it does now. Cool. Let's bring up the I am GUI window, and now I can move this around, right? So I can put it at the top there. You know what? And if I want to secure it again, I could. Like, for example, I could put that back. And the way you can do that is if you put a pipe character and you start typing I am GUI window flags, you can see that there is no move down here. No background, no collapse, no focus, no move. Hey, I want to put that no move back there. And if I run it again, right, you can see that I can't move the I am GUI window around when I bring it up, right? So no matter how much I try, I can't move it, right? Sometimes you want that, sometimes you don't. Next, I want to change these ones. So remember, just like we did last week, we don't care about this stuff. That's just for debugging purposes. We had that in there. We want to put the target to move, right? So we're going to say m_p target dot get transform dot position dot x and m_p target dot get transform dot position dot y. Those are the variables that we're kind of passing into this array. Let's rename this array because this array makes no sense. Let's go into right click and we'll go to refactor, rename, and we'll change this to position. Right? That's what that is, position. And we don't need 3 elements, we only need 2, right? So that's the first thing. We also don't need this to be a slider 3. We can make slider 2. And we're going to go from 0 to something like 800 pixels max. Okay, that's what we're going to do. Excellent. Nice. And what I want to do is take this part right here, this transform position for my circle, my target, and make it equal to a brand new GLM vec2 object where we pass in the position 0 and then we pass in the position 1. And that kind of passes in those 2 floating point numbers inside of a vector 2. And so we reset the position when we move the slider around. And let's change the name from my slider to target position, because this is our custom little element that we can use. So save and try it again. Let's run it. Bring it up and okay, cool, right? So now I can move this thing around maybe. Cool, excellent, right? All right, great. Let's put this up on GitHub, right? So again, going back to our GitHub desktop, I'm going to say added slider controls to move target. It's main and push. You can see I'm doing one feature, one push, one feature, one push. And that's how you should do it too. Okay, so are you with me? Are you able to do all those things? Check mark. We're going to do a checkpoint right now. Check mark if you're with me. X if you don't know what the heck I'm doing or you're way behind, right? I want everyone to respond as much as possible, please, so I know where you're at, okay? Because the next part is where you're going to have a challenge to do. Okay, so I'm seeing right now 7 people are responding. We got 9 out of 16. That's pretty good. I mean, we're getting at least half of you are doing something. Okay. How about the rest of you? What are the rest of you doing? Are you guys just watching? What's going on? Okay, well, let's move. We're going to move. We're going to get you guys to do the challenge. Okay, challenge time. It's almost like the bells are ringing. Challenge time's coming up. Okay, here we go. Here's the challenge. So I'm going to move all the way to the bottom of the slide. Challenge. Create your own Starship class and add it to the play scene. And the challenge ends, we're sitting at 2:33. Before, the last challenge we did was 1 o'clock, we ended. But let's talk about what I mean by that, all right? So remember, we have an example target class, right? And we have a target CPP. I want you to make a new class called Spaceship. It's going to use the new ncl.png that we put inside of the assets textures folder. Remember that? We did that at the beginning of the class, right? And so if you inspect that just before we start, just to inspect the, files here, so we can open this file in File Explorer. Remember what we did, right? We went into assets, we went into textures, and inside here we have this ncl.png. This is where it lives, okay? That's what it's called. Also notice the structure of our code, right? So we, hint, when you're adding your file, I didn't give a hint to the first class, right? I'm giving it to you and see what you did. Hint, when you're adding your files, be mindful of where they go, okay? That's the hint. Okay, so that's it. You're going to put the files in game objects. That's the filter you're going to use. You're going to put them in here and you're going to add a .h, so spaceship.h, and a .cpp, spaceship.cpp, inside of game objects. And then you're going to go to the play scene, just like we did before, inside of this start function and add it to the scene. Okay, so we're sitting at 2:34. I'm going to give you exactly 15 minutes like I gave the first class. So we're going to come back at 2:40. So the challenge ends at 2:40. Okay, it's 240. Let's see if you guys can get it done. I want you to do it on your own. All right, starting now. Go. 2, I'll be okay. 240 and 10 is 250. How about that? 250. I'll be able to count properly one day. 250. There we go. 10 minutes to 3. Go. Okay, no help from me. I'm going to just shut down for a bit. And I'm going to come back at 250. For those people who are watching on YouTube and you're watching this as a recording, just fast forward. And you'll have the answer. Alexa, Guys, how are we doing? Are we doing okay? Anyone done? It's about 10 minutes now. Some of you may have a chance to get done. If you're done, check mark. And if you're really, really far away from it and you think you're not going to finish on time in 5 minutes, X. Put that in there. Okay? And then we can talk about why, right? Some of your challenges. I got 3 people who say they're not going to finish in 5 minutes. 4, 5, 6. Okay. I'm going to give you some more time. Please work it out. And if one of you can, if you want to put in the chat some of the difficulties you're having, that might be good. And I want you to think of it this way. This is the lowest level of challenge. Lowest level. I'm not trying to scare you. I'm just telling you that's how it is. Okay, Visual Studio crashed. That's unfortunate. That's a system thing. What else? Anyone else have anything they can add to that one before we end? What other problems are you encountering? Your brain will scale. No, I don't know if your brain's going to scale, but it's going to change. It just needs practice. That's all it is. What else? What else, guys? There's a bunch of you here that have said that you can't picture yourself finishing on time. Ethan says, for some reason, I can't access the texture manager. Okay. Problem? Okay, Gershage says, problem is including files. No problem. I have problems with the including files. People are having the same problem. Okay. Same. And that's what's holding you guys up. Problem including files. Okay. Well, what you should keep doing is keep adding the stuff that you need. Before you can get rid of the error, add the things you need to your template so that when I show you the answer, don't be mad. But when I show you the answer, I talked about it already, right? There's a reason why things are the way they are. Okay, 3 more minutes. Try and just add the content to your class, and then I'll give you the answer. And it's not a trick question, by the way. This wasn't a trick. This was a challenge. So I can see if you understand the framework. And this means to me that we need to do more framework explanations. So don't be upset and don't get upset at yourself for any of this. It is what it is. It's your knowledge and your comfort with the framework right now, which is low. So at the end, what I'm hoping is that you're going to be more comfortable after this course. We're going to keep working and working to get you more comfortable with this framework. Okay. 2 more minutes. And if anyone actually finishes, check mark, please. So a lot of times what they say is, and I'll just keep talking while you guys are working, what they say is that we learn more from failure than from success. I don't want you guys to be discouraged though, because the fix that I'm going to show you is a one-time fix, and you're not going to worry about it anymore. The great thing about this is you might have tried a bunch of stuff without me telling you what to do, right? Because telling you what to do and giving you the answer, you're going to forget, and then you're going to get back to the point where you're at this point right here, where you're stuck and you can't get it done, and you're not going to know what to do, right? Because you haven't felt that frustration. You haven't felt that problem, which is like, I don't know what to do. I can't fix this problem, right? So what we're here to do, Alex and I, is to, catalyze your learning and to, take you to the next level. There is something that is wrong with the code, right? That's what the problem is. There's something wrong with the location. I told you that as a hint. The location of your files is the problem. Okay, you've got 15 seconds. And time. All right, so let's talk about it. And the challenge is over. So let's go into, into here and start thinking about it. Okay, so guys, what did you try to fix your problem? You guys said that you had all these problems with references. Basically, you can't include stuff. So what did you guys try to fix your problem? Did you do, what kind of debugging did you do? Does anyone want to share that? Did you guys do any debugging? How about this one? Did you know what debugging is? Yeah. Trevor says, I tried to move the file to SRC. Hey, that's a great idea, Trevor. That's an amazing idea. That would fix your problem. Gershad says, I tried to include the files in the SRC files. Excellent. That's a really good thing that you did. That's awesome. It fixed mine. Fantastic. Okay, great. That's what the problem was. So let me explain. It didn't fix mine. Well, I'll tell you why it might have not fixed yours, Trevor. Okay, so let's do what you might have done. Now watch this, okay? Let's suppose you did this. You said, hey, I'm going to add in a new class. You might have tried this, right? If you tried this out and it's going to say, hey, I can add in a class that's called spaceship, right? And notice it adds this .h and the .cpp, and it has these little ellipses. So you can actually describe where you want to put it to. But let's suppose you just did this and press OK, right? It's actually going to do some really good stuff. It adds it right down here. You can always move these things into the right filter, no problem. And it looks like they connect, right? Spaceship.h is found. And then when you try and add the texture manager reference, right, which is what you were talking about, and I want to use texture manager, it doesn't find it. Oh, man, why isn't it doing this? Well, let's take a look and see what happens. By the way, you would get the same result if you right-clicked here and you said add item and you added it separately. So if I added the CPP and the .h files separately, you can do that too. Down here is the issue. Look where it's going. Lab to template. That's not where my files are. Our files are all in the SRC folder. Okay, now it's not made on purpose. It wasn't done to freak you out or whatever. Or to frustrate you. It wasn't like that. But sometimes the structure of CPP programs in Visual Studio is one of the greatest frustrations that people get through. It's the way that it includes stuff, and we'll talk about some fixes this semester on how to fix that problem, right? Automatically, not just like this, right? So that's the issue. So when I added my files then, I added the spaceship files, but let's take a look where they went. So again, I'm going to go to my solution, right click and go to open folder in File Explorer. And you're going to see inside of the template folder, there they are. That's the incorrect place. They don't know how to reference from this folder into the SRC folder. That's a problem. That's a real issue. Now, Trevor, if you try to cut and paste, that will fail because these files here are references. That's what they are. They're not actual files in Visual Studio. They're references to the files. They're pointers, if you will, right? So what we need to do is keep this, but what we're going to do is remove it first. Okay, if you made this mistake, you have to remove. And there's two options. You can choose remove, which removes the items from the template, the references, or you can permanently delete. We don't want to permanently delete. We don't have to do that. We can just remove. And then, as an example, if you haven't saved anything, you can save it, and it'll be removed from the project. Now, let's use the operating system to move it around. So again, going back up to solution, I can open my folder. I can go into the template file folder where I have those two items. I can select them. I can cut them. So Control X. Go into my lab SRC folder and paste them. Control V. And you can see that they're both there now, right? Now they're still not in your project. They're still not here. You have to add them. So you're going to go to right click in your game objects and you're going to add existing item. And you're going to select both of those files by navigating to the SRC folder, scrolling down to spaceship, selecting both of those files and pressing add. You could alternatively, add them in individually, but it doesn't mean anything. So if I go to spaceship.h, I'm good. and spaceship.cpp. I'm good. This is the first step to having a problem. So now I can reference my texture manager right here. Now, the next step is actually using the template. So this is the big problem. This is probably the obstacle that stopped you from doing stuff. But let's talk about ways of doing this as well. So if I go to the target.h, I'm going to pull this target.h away so I can actually use it as a tearaway, right? So if I go back here, let's go to that target.h again. So I can pull it away and I can move it so it's here, 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 or here. Or I can put it back to take the whole screen up. I want to move it to the right, so I want to do a split screen, right? And what I want to do is literally copy everything here, including the pragma, copy, and I'm going to move to my spaceship.h and press paste for now. Right? And let's just change everything. So this will be called spaceship, right? And we can kind of copy that, and here, and here. So that's spaceship. We can change this to spaceship. Okay, still a display object. We talked about that. And we can use the spaceship to change the name of our constructor and destructor. We don't care about move, reset, and check bounce. We can get rid of that. Goodbye. And our .h is done. That's the first thing. So we did that with a target. We used this as a template, and we're ready to go. Right? We kept the inherited lifecycle functions, no problem, right? And let's go to the next piece. The next piece is something else we want to do. Again, I want to now focus on my spaceship.cpp and pull my target CPP over here again, right? I'm going to do the exact same thing. I'm going to copy everything other than the target itself. I already have texture manager, so I don't need to do that, but I can grab all this. And you're going to be, wait, Tom, but it says target. Who cares? Let's just go all the way to the clean function. I don't care about move, check bounds, or reset. So I'll copy and go over here and paste. And there's errors, and who cares? Because all I have to do now is I can go Control F, which pulls up the thing I want to search for, which is target. And then I can use this little pull down, and I can switch it to spaceship. That's the replacement for all references to target. Let's do so now. Replace. And we're good. Once I change those 7 replacements, everything is spaceship. A couple things that are missing. We don't have move and check bounce functions. We don't care about that, right? As an example. And we don't obviously want to load the circle. We want to load NCL. And we want to call this thing spaceship. Again, it's easier to destroy than to build. We can copy paste and save us a lot of time, right? And those are the things that we want to do at once. Spaceship, 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 instead of circle, circle, circle. NCL is the name of the spaceship. Where do we want the spaceship to start? Well, it doesn't make sense that it's going to be on top of the circle. Let's make it go something like 600 on the x-axis and something like 400 on the y-axis. Okay, something like that. We'll leave everything else the same there. It'll say spaceship, and we're ready to go. The spaceship has been created. Done. Okay. Again, don't be mad, right? Or frustrated. The idea here is that you should understand things that you can do to quickly create stuff, because when you're in your Game Production 2 course that you're going to be working right now with, if you're using a framework like this, there's going to be, things that need to be fixed. One more thing, actually, I forgot this one. This should be changed to spaceship. Okay, because that's the type of object that you're going to use. All right, cool. So save. And now let's add it to the placing. So the spaceship has been created. Let's add it to the placing. So again, what I'm going to do is just the same as before. I'm going to say include spaceship.h. It comes up. And just like before, I'm going to make a pointer to it. So it's going to be spaceship pointer m_p spaceship. Okay, so I declare it for here as a pointer, right, to the spaceship class. That's what I'm doing. And after this, I want to modify the placing.cpp to add it. So again, I'm going to go into the start. And underneath the target, I'm going to add the spaceship. That's going to equal to a new spaceship. I'm allocating memory. And then I'm just going to simply do an add child. That's it. And if everything went okay, we're going to see our spaceship right now on the right side of the screen. Let's see if it works. And if it isn't, we'll see errors and we'll fix them. It's good to see errors because then we can learn how to fix them. Hey, look at that. Right? So we got our spaceship and we got our little I am GUI. We're good to go. And what we've accomplished, is if we look up at the requirements, we've done this one, and we've done this piece, and it says push to repo for good measure. We'll do that right now, and we're not done yet. I want to talk about some stuff. Here's the repo. We're going to say we added spaceship to the play scene, and we're going to commit to main, and we're going to push origin, and done. So this is the first part of lab 1 part 2, or lab 2 part 1. But let's talk about it and let's discuss what you saw me do. So how are you feel now about it? Do you feel any better about what I showed you? What are your thoughts? Could you fix your problem with the solution that I showed you? What are your thoughts, guys? Check mark if you think you can fix it. X if you think you still don't understand anything. Okay, that's good. That's good. So the problem is it's understanding the framework. Remember, there's some challenges for you. Here's why it's a challenge. It's not your code. You didn't write this thing, right? We wrote it. And it would be the same if you work for a small company. Let's say you work, thank you for that feedback. Let's say you work for a company, as an example, that was an indie studio, and they had their own homegrown engine like this, right? Maybe even poor like this. And they said something like, okay, guys, here's our part of your training for today. We want you to add a game object. And you guys struggled and you felt terrible about it. And then someone came along, a senior programmer, and said, don't worry, it's just this. And you're like, darn, I can't believe I missed that, right? Don't feel bad because it's not your code. You didn't write it. If you wrote it, you would know exactly what the problem is because you would have figured that out a while back, right? Here, you've never done this. So now you've run into this problem. And guys, this is one of the most common problems when it comes to any kind of C++ stuff, which is the code is in the wrong spot, right? And your configuration files are not pointing properly to the code. They can't find stuff. You can change the configuration. That's one option. Or you can move the files into the proper folder, which is what we did. Okay, next. So one of the things that we're going to do, and we said that in our class, is what we want to do is we want to think about things like collision detection, right? So we said use collision detection functions to detect collision when ship overlaps a target. We're not going to do this piece because beginning a seek algorithm is going to take too long, right? But and this piece too, right? But we're going to talk about collision detection functions. So I've got a little diagram that I put together for you, and these are some options, okay? So in fundamentals, you talked about things like AABB collision detection. So that's axis aligned bounding box, right? Is what it stands for. So we could certainly surround our circle and our ship with a axis aligned bounding box each. And then we can just do AABB versus AABB collision detection every frame. But there are some problems. One of the problems are that you can see that there will be a logical collision here, but there's no physical collision between these two things. I mean, it's very small and it's hard to detect because they're so, these things are, I'm just going to zoom in here so you can see what I'm talking about. You can see that this object here is not really touching this one, but logically it's overlapping because I've got two bounding boxes that are overlapping, right? And this is not great, but it's not as bad as this scenario, right? Where everything is a circle, circle collision detection. And the way circle collision detection works is like so. I can take a circle. So this is my object, right? And what I'm going to do is when I kind of measure the distance from the middle of my circle to the edge, which is the radius. So this is the radius. I go kind of from the middle, to the edge, right? That's the radius. And let's make sure it's got the right color and the right size, just because, we're talking about some debugging. And we're saying, okay, so take this radius and add it to the other radius of the other object that you're colliding with. So again, from the center, approximate center, I'm just eyeballing it here. So something like this. And I want to draw another, kind of radius. So take these two lines, add them together. And if the total distance between the centers, is less than the combined radius, so this is the combined radius. So if I take now the true distance, so I go from center to center. Let's just change the color to red or something, right? Oh, not that one. Let's change the color to red for my line that I want to do. So let's change that color to red. Red. Let's make a new line. Okay. Okay. And let's try that now. Change the color to red. Excellent. And I want to go from here. This is the actual distance to center. If this distance here, the actual distance from center to center, is less than the combined radii, then one circle is inside of another circle, and therefore we have a collision. That is the algorithm, if you will, right? And that's okay if everything was circular, but it's clearly not true in this case, right? In this case, what we have some things that are circular, which is the target, and we have an object that's not circular, that's contained by a circle. So here we have a very big violation of user experience, where I have this object here, right? Let's kind of combine the objects. There we go. Here's the object, and here we have a logical collision, but there's no visual collision. The visual collision and the logical collision are out of sync. And this causes us to go, wait, I didn't collide with that object. How come I lost a life? Well, because our hit boxes or our collider system is flawed. This is not right for this type of scenario, right? So this is bad, and it's a lot worse than this, but this isn't accurate either. How about this, where I use like circles, a circle bounding area for circles, and a rectangle for rectangles. Again, it's very similar to this, even though this is more accurate because of it bounds the circles properly, right? It doesn't make much of a difference in terms of performance, right? This performance, AABB type performance, just to let you know, is probably computationally the smallest, kind of the least computationally expensive algorithm you can use, AABB, or circle. Those two things are the least computationally expensive, right? Depending on how you do circle distance checks, okay? The most computationally expensive is this one, this composite idea, right? And what you can do is you can take a circle and you can put it around the, kind of the saucer section of the ship. And you can put, for every nacelle here, because it's a ship from Star Trek, as an example, you can kind of surround it with these boxes, and maybe even the back area, you can surround that with a box, which is not exactly perfect, but better, as an example. And here you can clearly see that in this scenario, we'd have a collision, but here we wouldn't, okay? And you can bring a circle much closer, right, to the object, like here, and we can clearly see that there's no collision, but in this case, there would have been. So it's better, absolutely, but we're checking 1, 2, 3, 4 times every frame for just this object. And that is not realistic. So is it accurate? More accurate. Is it better? Maybe not as better as this, because this is almost as good, right? I mean, when it comes to how fast moving these objects might be, or this object, you might even be able to detect the difference because they're so close, even this one or this one, right? So choose my recommendation. The reason why I'm bringing this up is because people always think about pixel perfect collision detection and separating axis theorem and a bunch of other stuff. Yeah, that's all good stuff, but is it overkill is the question. If it's overkill, don't use it, right? Sure, we can do this if we really wanted to in code, but should we? And the answer might be, this might be good enough. And what I want you guys to do for this semester is, what is good enough? That's the question you should ask yourself. Is it good enough? Does it look good? If it looks good and it responds well and it's kind of what you were expecting, it's good enough. Don't try for perfection because perfection might be computationally expensive. We're not doing a simulation. We're making a game. If we're doing a simulation, then perfection is required. We want to make it as accurate as possible, right? That's not what we're doing here. Okay, we're making a game. We're using AI to give some kind of behavior, to your enemies. That's what we're doing. Okay, so this is part of it. Let's do some testing. And I want to talk about the framework because you also need to learn about the framework here. So one thing to note is that we have something called a collision manager. And the collision manager is not a singleton. And there was reasons why we didn't make it a singleton. Why? Because we never have to instantiate any object in here as well, right? We can have multiple calls to the collision manager and it's okay, right? We're not storing anything in the collision manager. I'm not storing data, right? All I'm really doing is using the functions. Think about this as a wrapper class. That's really what it is, a wrapper class. And this wrapper class or a container class just exposes, all of these things. Notice I've made the collision manager constructor private and the collision manager destructor private. So you can't even create an object of type collision manager, not even by accident. It'll error out, okay? And so how do I use this thing? Well, there's some built-in things that I've given you. I've got an Aabb check that checks between two game objects. Cool, I like it. I like it. And there's another thing we can do, right? We can also do a circle Aabb check. Let's do both. Let's talk about how to incorporate both pieces of code to check and where to put it. Okay, so I want to do collision detection. Broad, right? Very, very simple collision detection. I want to use Aabb check first. How do I use it? Where do I put it in the scene? Well, we know we want to detect it every update. So every time, the update function is called, this one, right? We want to check to see if things have moved around and if things are overlapping. That's when we want to check it. So in here, we're going to use the collision manager. I'm going to say, hey, collision manager, I want to use the Aabb check, this one, top one. And I'm going to pass in my two objects. I'm going to check between the circle, which is the target, and my spaceship. So m_p target and m_p spaceship. That's it, right? That's the check. Okay, cool. What does this do? Go to definition. Let's see if we may have to customize something. Okay, cool. So it takes the two objects. It gets information about their starting positions. Each Aabb has a top left and a bottom right. And then what we do is we do a simple branch check to say if my, the x is less than p2.x, and we compare if one thing is inside of another thing. We do these little 4 checks, the simple way of doing it. And then we know it's colliding. If this is true, anything in here is colliding. But we want to know what is colliding. We don't care about target. We're using a switch case. Okay, we're using a switch case. And the switch case is switching on the second object. So object 2, we're saying, hey, get that type. Remember we talked about the type as, being, for example, the spaceship or the target or whatever. We can check that type. And if in case that type is a spaceship, right, then what we can do, I'm just reformatting so you can see it easier. We can do, right, is we can say collision with spaceship. Hey, that is what we know. And one thing we want to do also is we want to make sure that it only happens once, right? So we're going to say this. We're going to do a simple check here, a line 69. We're saying if my object is not colliding, right? We're not already colliding, then check to see if we're colliding. Okay, so this is kind of a simple way of checking it out. We're saying if the object isn't already colliding, okay? The challenge here is it's inaccurate, right? There's some inaccuracies here. Let me explain, right? Going back to our diagram, we're saying we're only checking these two objects, right? We can say that, okay, fine, if the Aabb, this object, which is any one of these two things, are both Aabbs, if this is the first object and this is the second object, if the second object is not already colliding, then check. But what if it is already colliding with this one? Well, then we won't check for this one. This one will just go right through. That's what this is doing, right? It's very simple. We need to add additional code if we had multiple objects in here to basically say, hey, maybe what we need is a collision list so that the collision list is empty. If the collision list is empty and I'm not colliding with that object, I'm searching for both objects in the collision list. Am I colliding with this object already? If I'm already colliding with the object, don't let me know that I'm colliding with it again. I don't care. I only want to collide once, right? And you may not understand what I'm saying, but you'll see. And you know, at the example that we have here, let's just say that we want to use this thing. We're using the switch case to check to see if object 1 is colliding with object 2. Let's try this out and run it and see what happens. Go. All right, cool. I want to move, you know, my target down to my spaceship. Let's try this out. So move it, and let's move it kind of towards the middle and drop it down. And as I approach, take a look at the log there. Over here, we're not colliding yet. But as I get closer and closer, then either we miss or we're colliding. Are we colliding? Should we be colliding at this point? Should be, right? Should be. But we're not. What if I'm closer? So what if I get closer? Hey, look, now we can collide with the spaceship over and over again. Well, we got to get pretty darn close. I got to get pretty darn close, right? Like here to start colliding. Why? That's weird. Where's the bounding box for this thing? So one thing we can do is we can draw the bounding box. And inside of our draw function, to make sure that it's more accurate, right, we can start thinking about how to collide, right? So this is just one collision detection formula that we're using here in my playscene.cpp. It's saying, hey, check these two and see if they're colliding. But what is it checking? M_P target and M_P spaceship. Okay, cool. What does the collision manager dot Aabb check do? Well, it says, okay, so my P1, so object 1 or P1, point 1, is the position of the first object. Point 2 is the position of the second object. Okay, point 1 dot width is object 1 get width. Okay, point 1 dot height is object 1 get height. Okay, and same thing with the other ones. And what I'm saying is check to see if my point 1 dot x, so the x value of point 1, right? And what is this? Point 1 dot x, well, if both objects are centered, point 1 dot x is the middle position. So if the middle, not the top left, that's what this should be, the top left, right? This is incorrect for this kind of Aabb type check, right? And to show you this, right, the reason why this is going to give you an erroneous value, not because I wanted to plot it this way, because this one here, P1.x, what this means is the top left corner. That's what this should be. Top left corner, P1.x, right? The minimum, if you will, right? Is less than P2.x. Where does the other one start? This is not the start. This is the middle, right? Because we're saying object 1 and object 2. This is just doing what we're telling it to do, right? And it's incorrect. Let's draw it so we can picture this. So I want to draw, and the way to draw anything is to use the util library. So I can say, hey, util, I want to draw, and there's some stuff we can draw. Let's draw a rectangle. Okay, and it's going to ask you for some information. It's going to say, okay, I need to draw the position, right? The width, the height, and any color. Position, width, height, color. Let's see what it does. Okay, so position, I want to do this, right? And I want to do get transform dot position, and the width is M_P target dot get width, and M_P target, right, dot get height. So there's the height, the width, and the position. I've got all that stuff in there. And let's make sure that's a function. right? Get height, get height. There we go. No, that's wrong. Get height. Ah, autocomplete. And maybe we can have it a dash arrow instead of a dot. Cool. So let's see what that draws. If I just draw one object, I want to draw the target, right? And I'm using AABB, right? So let's draw that out and see what happens. Oh man, what happened? Well, remember, this draw function is happening, right, every frame, and it's happening on update. So what we're going to do is we're going to pass this into the proper place, which is up here. So before we draw color, it's going to be here. It's going to be in the draw function. Let's try that again. Before we do render clear, and we might have to put it in a different spot. There it is. That's what's really happening. That is exactly what's happening. Okay? That is what's colliding. Okay, let's do the same thing with the other thing. We're going to do another one of these draws, and we're going to draw for the spaceship. So this is draw target, bounding box, right? And we're going to draw. This is just for debugging. Okay, we're not doing anything here. This is not part of lab 2 part 2 yet. I'm just giving you some sense of how this works. So don't get mad is what I'm saying, right? Because you might think it's easy, but again, it really depends on what we tell the computer to do, right? The computer, our program, is only going to do what we tell it to do, and nothing more. It's not going to be intelligent unless we program it to be, right? So now let's see what it looks like. That's what the representation is. That. So there's a couple ways we can fix this. We can fix our function once and for all. So you give it an object, and it finds the top left corner, right? It finds the top left corner for you, a more intelligent function, right? Or you can pass it different information. Let's show you what this does now, and so we can see how accurate it is when it's right. So again, I'm going to move this down, and then only when it collides, let's move it so it doesn't collide right now. So right here, there's no collision. See, no collision. And let's bring it closer. So we're going to bring it closer, 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 closer. No collision still, look. But as soon as we overlap these boxes, oh, there's a collision. Oh, there's a collision. You can clearly see that I'm right now, right? That's what I'm talking about. That's why it is the way it is. And so what you're seeing and what you're expecting are two different things. All right, so how to fix this problem? Well, can we fix the problem? That's the challenge with our Aabb check. Our Aabb check is passing in two objects, object 1 and object 2. We're passing in object 1 and object 2, right? What we need to do if we're going to use the Aabb check is fix the function, go to definition. And in that function, it says that the P1 is the position. But we can check to see if the object over here, if the object is centered. If the object is centered, then what we can do is we can readjust P1 if the object is centered, right? If the object is not centered, this is assuming that the object is not centered, okay? It's not centered. So if the object is centered, let's check. Let's do a check here in our collision manager Aabb. We're just changing the function. If, right, object 1, right? And then we can say, okay, well, how do I check to see if it's centered? Is there a way of checking it out? So I have set type, set enabled, set width, set visible, update. But is there any place that it tells us if it's centered or not? Do we keep track of that it's centered or not? And the answer is we don't. We have to build that functionality in. And that's got to go to the highest level of our code, right, to fix. What that means is there's two ways. We can fix our game objects, we can fix our stuff, or we can fix this. Here, if we fix this, that means we're always going to assume that the game object is centered, right? Or we can have a switch at the end. We can modify our Aabb, right? Or we can say if the Aabb is switched, right, as an example, switched around, then we do something different than what we're doing here. So in order for us to do that, we need to change it at the collision manager level. We can say, okay, fine. Or we can make another overloaded function that takes in a true false. It's centered or not. The objects are centered or not. But that's assuming that both objects are the exact same. Again, maybe not what we're looking for, okay? So at the very best case, what we want to do is modify the game objects themselves. So going back up to the core, right? We can look right up at GameObject.cpp and see what we get. So here's GameObject. GameObject has get height, set width, set height, set type, all this kind of stuff. But we never keep track of, is it centered or not? We just know, width and height and stuff like that. We have no Boolean that says, the pivot is centered. We have no idea, right? And the same thing goes with our display object. Take a look at our display object. Is there any properties that tells us it's centered? The answer is no. We have no idea, right? So it would be nice if we added it in. And again, it's something we should consider. How would we do it? We could put it in here. We could say bool m is centered, right? And if we say is centered, it's either true or false. We can align this, right? We're setting up a new property that's going to cascade down from the game object to every other object in the scene. That's how we're doing. We're modifying it from an OOP perspective, right? Cool. I like it. Okay, this is pretty cool. And so how do we do that? Well, we need a couple things. One, we need some getters and setters to support this. So let's make some getters and setters. Void set is centered, right? So again, we can have a bool with a state, just like we've done here. And a bool is centered, right? And it's got to be different name than this. Notice that there is no m underscore, right? Which returns a constant value. So those two things have not been created. Let's make them. So what I'll do is I want to generate this, and you can do that at the very top actually of the code. If I right click, it'll say, I can add anything that's not already there, right? So it says go to implementation. I can do that, right? As an example, I can do it manually as well, right? Or a lot of times there'll be some kind of suggestion, an action list, right? That'll come up and says, generate definitions by declarations. This is a ReSharper thing. And it'll pull up some stuff I can generate. I don't care to generate these ones, but I do care to generate these two automatically. So I'm going to press finish. And then the system is going to generate these two things for me. Set is centered and is centered. Okay, so what I can do is set is centered. I can say that m underscore is centered is equal to whatever the state is, centered or not, right? And I can also say that, right, return, right, m underscore is centered. So I can get access to this private variable that's way up the food chain right now. How do I use it? How do I make it viable for me to use, right? Well, whenever I declare an object, I can detect if it's centered or not, and that's based on when I create it. So for example, in the spaceship.cpp, remember, I do something that looks like this, true. When I target manager, draw, I want to draw it if it's centered or not, and I'm making it true, okay? So instead of making this true and hard coding it, I can decide that up here. I can say something like, okay, let's say that one of my things is, I can say that is centered, or set is centered, because now it's available, is true, right? And then what I can do is I can put whatever it is here is centered, right? So now instead of me hard coding it, whatever I put there is going to be the way it's going to appear. Nice, I like it. But we need to make one more change to the GameObject.h and .cpp. The GameObject.cpp has to initialize, right? So by default, do we want to make an object centered or not? That's also something we can say. And if we say we want to make all objects centered by default, which might be the right thing to do, right? Then I can go here and say m underscore is centered, or set is centered. Sorry, actually it's the m underscore. Set or is centered is true. So all objects are centered by default. if this is true, and we're doing it in the constructor function of the game object super duper class, the way up above everything else, then inside of my spaceship.cpp, we don't need to do this, because by default, all we need to do is check to see if it's centered. If it's centered, that's how we're going to draw it. If it's not, we can choose it. We can change it up here, but we don't have to set it here, okay? Which is pretty cool. And same thing goes when it comes to my spaceship, my target. So let's go to target and change that. Now, keep in mind, we're modifying the entire core, right? Once we've added that feature, we're adding it everywhere, all right? So be careful about that. Could it trip us up? Absolutely. But we're being brave. So let's go into my target.cpp and do the exact same. So instead of putting true, we're going to put down is centered, right? We're going to check to see if it's centered, and if it is, that's what's going to happen. Hey, now we have a mechanism we can check inside of our collision manager. We can sit there and say, okay, I can check if this one is centered individually from this one. Let's do that. So if now object1 dot is centered, notice I can do that. If it's centered, then what do I want to do with my values, right? Then I want to change my P1 value, my position. It's got to change, right? And I want to do an else. If it's not centered, then do something else with P1. Do this with P1, right? This. So if it's not centered, do this, you know, as an example. And if it is centered, do something else. Do something else. I want to set my position minus the width, whatever that is, right? That's what I want to do. I don't have to do it up here, by the way. Okay, I'm just saying it can be done anywhere I want. Let's go back and put those back for a second. And let's move this before we do our calculation for collision detection. Let's do that down here. All right. So I can say, okay, if object 1 is centered, then what I want to do is adjust my P1. So I can say that P1 then, right, is equal to, I want to subtract, right, or I can add, whatever you want to call it. I can go plus equals, right? So let's do that. So plus equals to, I want to add a new GLM vec2 object. That's my P1, right? Where I want to add in I want to march back P1 width, half of P1 width, and I want to march up half of P1 height. Why? Because I'm going from the center back and up, right? So we can realign what I'm checking, right? So let's do that. So again, it's nice to say plus equals, but we can't. We got to say is equal to P1 plus. That's what we're going to say, P1 plus. So P1 is the position. Position is a GLM vec2 object, and we're just saying P1 is equal to P1 plus some GLM vec2. Right, that's what we're trying to do. We're kind of equating this one, right? It says to the original one that we had plus some GLM vec2 object. The GLM vec2 object we're adding is going to be half the width. So we're going to say P1 dot, and we want to say not just P1, that's the whole position. We want to say P1 dot X. That's what we're going to modify, right? We can do that too. P1 dot X is equal to P1 dot X, right? And we want to modify, we can do step by step. We can say minus half the width. So P1 width times 0.5F. Okay, can I not do this? Well, why? Because it's const. So let's get rid of const. And that's why it's giving me those errors, because we actually, this can be still const. All right. We could also have done it the other way, where I wanted to do, instead of just P1 or P1.x, I can do the same thing. I can say P1 plus equals to, right, a new GLM vec2 object where I pass in the width, subtract the width, so negative P1, negative P1 width times 0.5F, and then negative P1 height times 0.5f. So that kind of moves it back and up. If the object is centered, we don't need the else. Okay, that's only if the object is centered. And if I can do the same thing with object 2. So instead of object, 2, if object 2 is centered, we can check now. And we can add this little piece of code here that we can do the exact same thing, but instead of P1, we want to say P2. And then what this does is when we come down here and do our check, we have the exact location for where this is happening. And the same thing goes with when we draw our debug. So I'm going back to my debug, right? Hey, look, if I'm drawing my debug, I can draw it differently. We know that we need to march back. So our position is not accurate for the start. That is not the position. The width and height is good, but I need to subtract. That's what I need to do. A GLM vec2 object, and I can kind of cut this across 2 lines so I can show you, right? Which is the m_p target, dot width, get width, right? Times 0.5, and m_p target dot get height times 0.5, right? So I'm going to subtract that, right, from the position. So I march back half the height and half the width and half the height, and that'll draw the correct box for the target. And I got to do the exact same thing for the ship because, again, it's centered. We know this. And this is just a debug thing. So again, we're going to say minus GLM vec2, and we're going to pass in the spaceship. Actually, let's just copy this whole thing and just change the values. So we're going to take this and put that here. And instead of target, we're going to use spaceship. Okay, and we're going to split it across 2 lines to make it easier to look at. So we're going to go from the comma here, and we're going to go enter. And we probably should have done the same thing here. Okay, so 2 lines, we can see that's the same thing. And now when we save and we go, I know that this is a lot of changes, but I want you to get a sense of what the problem is, because you won't know what the problem is until you start thinking about it, right? Why isn't it checking properly? Why isn't it drawing properly? Well, it's not drawing because the centers, it's drawing from the centers. Take a look now what it looks like. So I've redrawn where this thing starts from. Now it's more accurate. And let's pull up our I'm GUI window and march across. And let's see how accurate it is when I march across, right? Here, I'll put it over here. March across and then march down. Soon as it hits this spot, then we should see a collision. Look at that. And let's march it to the left, right? See that there's no collision, and march it down. And this is where the problem was. It didn't collide, right? And I'm going to march it left, right, right, right. Take a look at the collision, and oh, now there's a collision. So it's way more accurate than it was before. And that's your AAB collision detection. Does this make sense? What are your thoughts? Again, this is not part of the lab today. Does it make sense? Okay, I got a couple of people saying yes. You're seeing what's happening. So this is one way to do it for sure, right? We fixed the AABB collision detection. That's what we did. We had a problem with this function. This function didn't care. It always assumed that the AABB check was not centered, that it was at the top left corner of the screen. And that's an issue. That's a huge issue for this function. Okay. Let's do the next one. Let's do one more, and we'll change it from AABB type check. Okay, so we'll comment this out. So we have this as a, and I'll put this up later on so you can see it, right? And I want to comment this out too. So all of this, because this is only good for bounding boxes, right? So let's comment this out. And instead, what I want to do is I want to draw circles. Let's do circle, circle. And let's see how that, or sorry, we'll do a circle bounding box. We'll use one of the bounding boxes in the circle. Let's see how that works any better, right? Because people said, I prefer a circle bounding box. I heard that earlier today. Okay, cool. There's a function for that, right? Let's take a look. So it looks like this. Hey, collision manager. Let's go with a circle Aabb check. Okay, nice, nice, nice. Let's pass in the circle M_P target and the bounding box M_P spaceship. More accurate, okay? More accurate and a little bit more computationally expensive than this one. Okay, cool. Let's use the bounding area for the spaceship. The spaceship was correct. So we can do that. We can say the spaceship, we can undo this because we can draw the spaceship, but the circle, we can't draw a rect. Let's draw a circle. Okay, so we'll say, let's draw it, util, and then we'll say draw circle, right? And what we want to draw. So again, if you look at the circle itself, it says draw circle. What's the center of the circle and the radius? Circle and radius. Okay, cool. Circle, M_P target dot get transform dot position. That's the center. And then the radius is the width, right? We know the width and the height of the circle are the same. So we'll just use one of the values. So we'll say that M_P target dot get width. That's how we're going to draw the circle, okay? Well, we have good representation of what we're drawing. So when we run it now, you'll see that the circle is a circle, right? There it is. Oh man, what the heck? And this is good. Why did it do that? Well, because we did the whole width and we need to do half the width. So that's more accurate, right? Half the width of the object is the radius. The whole width is the diameter. So now we're going to draw it properly. There we go. Nice, nice, nice. But does it collide properly? Do we consider that this is centered or not? Let's see. So bringing up I am Gui. Do we have the same problem is what I'm saying, right? So again, going here and scoping down. Is there a collision? No. And this is the problem. So it's going to kind of slide it over. And look, we should be colliding right now. And it's not colliding at all. Oh man, that's like really bad, right? How come? Well, there's a couple reasons. Let's go and take a look at our code because we didn't complete the circle Aabb check. Let's go to definition. In our circle Aabb check, we have a lot of extraneous information. One is we have this attack vector, dot product, and angle, and something that was used from before. So let's just comment this stuff out. We don't care about this stuff, right? And we don't care about all of this. We're just going to get rid of all this, right? We don't care about all this in here, right? We didn't do all this work yet. We don't care about the target being the one we want to care for. The second object is always going to be the spaceship. So that's what we want to care about. We don't care about the collision manager, but we do care is about kind of outputting a message that we kind of use with Aabb check. I'm just going to go grab that message right now, which is this message right here. Okay, so I just want to replace all this with that message, collision with spaceship. Okay, and let's just reposition and realign and all that kind of stuff that we did before. So it's going to grab all this, all the stuff that's in the middle, and just move it over a little bit and make it look a little nicer. And now let's check to see if everything is good. Okay, if object 2 is colliding, the same problem as before, that's fine. And okay, what's the type? It's if it's a spaceship, collide with the spaceship, and everything else is okay. The rest is commented out, right? We might even be able to get rid of it. Why? Let's just get rid of it. We don't need it right now. If we need to, we'll put it there later. Okay. And we use something called a circle Aabb squared distance check, where we pass in the circle center, the circle radius, the box start, the box width, and the box height. Uh-oh. Uh-oh. What is it saying? It's saying that the box width is equal to the width, And where does the box start happen? The box start is, okay, now it's assuming you're centered. This is also incorrect. This is going to work actually, because saying box start is equal to whatever the position is minus GLM vec2, half the box width and half the box height, which is kind of what we did up there, but it's always assuming that you're centered. What if the box isn't centered? Then this would fit, right? So this is actually going to work, but it's also incorrect. It's making some assumptions. All right, cool. Let's try it again and see what happens. So now, is it as accurate? What's the performance? How does it look? And do you agree with this one as well? So there's two shapes here, two collision shapes. Look how accurate it is, right? As soon as I touch, we're good to go, right? So it's just as good as the other one. It's just as good, right? But in this case, it wasn't as broken for AABB type collision detection. So either way, whether you use a Aabb check or a circle Aabb check, it's okay. The one that was broken was this one. If we use circle check, that would be bad. And if we try to do something like this, that would be a lot of work and computationally expensive. Okay, this is just the lesson. Questions? What are your questions? Do you get it? We're going to put this up on GitHub because I'm timing out now. So I'm going to go to here and I'm just going to add this in. So I'm going to say added simple collision detection examples. That's all I did. Okay. It's not really the result, the end. We're going to do more, but I wanted to talk about it here with you because it's something that we need you to know. So no questions. You guys are golden. You guys know everything, right? Just curious. Ethan says yes. He knows everything. That's awesome, Ethan. Efrain says no in his own way, right? Anybody else know everything? The idea here, guys, is don't be afraid. You'll get it as you do it. You learn by doing. And the idea here is that we need to understand this. If you don't do this, you can't make games without doing some kind of collision detection. Collision detection to me is the heart of how we start playing games, how we do platforming, how we do, bullets, how we do everything. Everything is from collision detection. These are the basic shapes we're going to deal with right now. And we also have another one, line box collision detection or line circle collision detection. So we can do raycasting for AI, all right? Okay, that's it for me, guys. That's it for today. Again, for today, I recommend you go as far as I went before I did all that crazy collision detection stuff. As long as you're able to add a spaceship, next day what we're going to do is we're going to do the next part, which is the seeking algorithm. Okay, and we're going to use one of these collision management techniques in order for us to detect collisions. Okay, that's it. Questions before we go? I'm just going to check like this 4 times over this weekend. Okay, no problem. I know it's difficult and it's a new thing for you guys, but I want you to consider what's going on here. And so you understand what's happening. We didn't even fix the last one. Absolutely, we can do the sprite sheet next week, no problem. We can make our own sprite sheet too. Okay, guys, thank you so much. Take care, and we'll see you next week. I'm going to stop sharing right now, and I'm going to stop recording on YouTube. Take care.